Hi everyone, my name's Anand Mehta and I am a product manager at Microsoft. Welcome to today's session on getting started with Azure Container Storage. For today's agenda, we will cover an introduction to Azure Container Storage, providing an overview of what this new product is and how you can use it for your container storage needs, followed by a quick demo on how to use Azure Container Storage. In recent years, containerized applications have gained popularity for packaging and deploying applications on cloud for better portability, scalability, and efficiency. Containers offer a lightweight and portable approach to software development and application hosting, enabling developers to build, test, and deploy their applications quickly and efficiently. Azure offers a variety of container offerings like Azure Kubernetes Service, also known as AKS, and Azure Container Instances, also known as ACI, to offer easy hosting for your containerized applications. However, container hosting only solves a piece of the cloud-native puzzle. If you plan to run PostgreSQL, Kafka, or any other types of stateful applications on an AKS cluster, you need persistent volumes to safely store your data. Many container storage solutions on the market were built for infrastructure as a service or IaaS-centric architecture and retrofitted to containers, which in turn creates a huge operational overhead when deploying, managing, and upgrading these solutions. Some specific pain points that can arise through this are the inability to match the scale out speed and target of containers or pods, slow pod failover resulting in degraded availability of stateful containers upon matching scale needs, and limited coverage of available storage offerings. With swift Kubernetes adoption, teams deploying stateful workloads need a container-native storage solution, often called container-attached storage, that presents all cloud infrastructure storage offerings with a container-friendly interface and orchestration experience. Therefore, we are excited to introduce Azure Container Storage. Azure Container Storage is Microsoft's new container storage offering that enables you to focus your attention on running workloads and applications rather than managing storage. Many of its benefits are the ability to deploy and manage storage as code programmatically through the Kubernetes API, surfacing block storage of different performance profiles for read-write-once scenarios through a single pane of glass, optimizing persistent volume or PV placement for maximal cost savings, enterprise-grade scale availability, and backup continuity and disaster recovery support. And all of this is installed in your AKS cluster as a Kubernetes cluster extension through Azure Arc. Azure Container Storage introduces the concept of container storage pools, where a pool is a grouping of storage resources that are presented as a single storage entity for your AKS cluster. Existing Azure storage offerings like ephemeral disks, Azure disks, and managed storage, which is backed by Azure Elastic SAN, can all serve as resources backing a storage pool. You can create a persistent volume in the storage pool and mount it to your pods to store data. We built Azure Container Storage with built-in capabilities that help you achieve better cost efficiency, scalability, and reduce management overhead. Starting with the first benefit on reducing total cost of ownership, also known as TCO, when deploying persistent volumes, they are placed in the storage pool, which optimizes its placement against all available storage to maximize the price to performance ratio. Instead of mapping one persistent volume to one disk, Azure Container Storage can pack many small volumes to one disk to maximize utilization. Moving on to the Kubernetes native orchestration, the management of storage pools, snapshots, and persistent volume lifecycle can be done with preferred kubectl commands. No longer will you need to switch between tool sets for various control plane operations. Rapid scale up and scale out. Azure Container Storage reduces persistent volume creation time and increases scalability limits, supporting the creation of 3,000 stateful pods at a fraction of the time. And finally, a unified storage management experience where a consistent view to manage all your backing storage offerings is available in a single vantage point. The block storage offerings that are available in Azure Container Storage consists of the following. Starting with ephemeral disks, This utilizes local storage resources on AKS nodes to provide this. The workload recommendations are extremely latency-sensitive workloads or applications with no data durability requirements or built-in data replication, such as Cassandra. The offerings for ephemeral disk consist of temporary storage and NVMe drives. Moving on to Azure disks, this utilizes granular control of storage SKUs and configurations to meet your desires. Tier 1 and general purpose databases such as MySQL, MongoDB, and PostgreSQL are recommended workloads that can be used here. The offerings that support Azure disks consists of Premium SSD v2 and Premium SSD. The last bucket is managed storage, which is backed by Azure Elastic SAN. This provisions on-demand and fully managed resources whenever they are needed. Workload recommendations consist of general-purpose databases, streaming services, CI/CD environments, and other Tier 1 and Tier 2 workloads. Azure Elastic SAN is the storage that powers this offering. In today's demo, we will deploy Azure Container Storage on an existing AKS cluster. Then we will mount a persistent volume in a stateful pod utilizing Azure disks. At a high level, we start by deploying our extension in our AKS cluster that requires a step involving managed identity. Once that extension is installed, we then move on to the storage pool deployment. Here, you specify your storage pool capacity, the resource you would like to back the pool, then create the pool. Upon pool creation, we then select our storage class, which is based off of our SKU selection and reclaim policies as important areas to look into. Once we've selected our storage class, we then create a persistent volume claim where we specify the name and capacity needed. Once the persistent volume claim is deployed, we then mount our persistent volume by preparing a pod, the correct mount path, then deploy the pod, which will then mount the persistent volume. We will now move on to a demo where we will create and mount a persistent volume using Azure Container Storage. Here's the AKS cluster that we will use for today's demo. I did want to call out that in our node pool, we have 3 machines with a minimum of 4 cores or vCPUs that are required for installation of Azure Container Storage. The first step of this process is to log on to your cluster, which I am doing here. In this step, we will label the node pool for Azure Container Storage's installation. Once this is complete, you will see an output similar to this with the status of succeeded. This can also be confirmed directly in your cluster. I have navigated to my cluster into the portal. I am going into the node pools and can confirm the node pool is appropriately labeled for Azure Container Storage. Once this is done, we then must grant the managed identity from the managed AKS cluster access to create storage on our behalf. This can also be done in the portal. The first step of this process is to locate your managed cluster that's created by AKS. We look for the agent pool managed identity, noting its name, which we will then subsequently grant contributor access to this resource group. Clicking on the Access Control tab, and then the Add Role assignment, we must select the Privileged Administrator role with contributor level access. And here we are granting that to the managed identity we previously saw. Once that has been clicked, we can select the appropriate member, searching for that name. We have now selected the appropriate managed identity, which has now been successfully assigned. We are now ready to install Azure Container Storage onto our AKS cluster. I will be doing this through the extension command. Upon completion, you will see an output similar to this, but you can also validate that the installation has been done successfully with this command. As we see here, the provisioning state is set to succeeded, indicating a successful installation. Now that Azure Container Storage has been successfully installed on my AKS cluster, I am now ready to create a storage pool utilizing Azure disks. In this case, I will be creating a YAML file to help me achieve this. Please note in this YAML file that I'm requesting a size of 5 terabytes for this pool, and under the specifications, the type here is indicated as CSI, which indicates our Azure disks powered by our CSI drivers. Upon successful configuration, we then apply this to create our storage pool. As we see here, the output has indicated that our storage pool has been created successfully. To ensure the storage pool has finished provisioning, we can run this command to check its status. As we see here, it is actually not ready, and we can check this again in a minute. Upon running this command again, we see that the storage pool is now ready to use. From here, we must select the storage class we will use to build our persistent volumes. By running this command, we see what available storage classes are there for us to select from. In this case, we will be using the Azure Disk Storage class that I had specified in the previous step. Please also note the reclaim policy, volume binding mode, and volume expansion modes to ensure that they match your needs. Now that I have selected the storage class that I will be using for my persistent volume claim, I am now ready to create that YAML file. And here I am titling it Azure Disk PVC with the read write once access mode, utilizing the Azure Disk Storage class that I had previously mentioned, and we are requesting a size of 100 gigabytes. We then apply this YAML file to create the PVC. As we can see, the output here indicates that the persistent volume claim has been made successfully. We can also verify the status of the persistent volume claim by running a describe command. And here, we see the PVC is ready for us to mount onto a pod. I will now create a pod utilizing this PVC. In this scenario, it is an FIO pod that utilizes the flexible IO testing for benchmarking and workload simulation. Here I reference the Azure Disk PVC that I had just created, and also specify the mount path where the persistent volume should be mounted to. We are now ready to deploy our pod. As we see here, FIO pod has been created successfully. We can also verify this by describing both the pod and the PVC to ensure that they are running successfully. As we see in the pod, the volume has been attached successfully. Additionally, the PVC also indicates that it has been bound successfully to the pod. From here, we can also check our FIO testing to see its current status. And as we can see here, the 8 processes that I had indicated are occurring, which indicates a successful pod creation and persistent volume mounting. At this stage, we have installed Azure Container Storage to an existing AKS cluster. We have created our storage pool utilizing the storage that we would like to use. We have then selected the storage class that we would like to build our persistent volumes from. We subsequently created a persistent volume claim, then created a pod utilizing that claim, which has successfully mounted a persistent volume for a stateful pod. Thank you for joining me today on exploring Azure Container Storage. Please visit the blog and other links here for further information. If you're eager, see our onboarding survey to get started with Azure Container Storage today. I hope you enjoyed this overview, and thanks for joining us.